All right, I think everybody knows what my plan is here. That I'd like to have everybody contribute to this paper, and we'll publish it and hopefully get some attention and make this stuff known that it is what it is. And right now it's being considered to be just rocks, and they are not just rocks. So Tom is going to do the DNA, and the stuff is on the way to you, Tom. And here's your little fascia right there, some elastins. There's that slurpy layer. That's where the tendon invests. Anyway, that's the fascia. Now, David is a structural fascia guy, and this is his realm right here. This is the stuff that he does. And this is the kind of stuff that I want him to comment on for the paper. Between his comments, my specimens and work, scanning a visual, DNA analysis. I mean, what the hell? If we can't get it accepted now, I mean, you know, but I need everybody, so everybody's got to be on board. Anybody doesn't want to be in on this, let me know now, because this is, and this really, literally is one of the biggest things going, I mean, I think. Anyway, stay tuned. The rest is coming right now. Okay, I'm going to let this little slideshow go with some of the pictures we have. That's the actual, I made that with chicken tissue. And that is chicken tissue. Also, all of this stuff in the beginning here, look at that. That's the facial investment, looks like, of the chicken tissue. And that is actual fossil that was electrofossil, and that is also a fossil. So it's very, very similar. But anyway, okay, this is the tendon assembly. Now remember this carefully. There's like 3 sections, and it comes down, they're wavy, and then they get smaller, and they end up with, you know, those little emphasis points, and investing in Sharpie's fibers and bone and tissue. All right, as far as tendons and ligaments and fascia and all that stuff goes, it's all made out of collagen and fibrins and keratins and all this very, very fibrous stuff. And it has a mat. That's the mat of a tendon. And in the mat, it splices off into these little straps. These straps go through what they call a Chinese finger trap, which goes through that, and the ball there invests into the tissue below, or in this case it would be tissue, I'm sure. Now, that ball, if you can see that little round ball, that should not be out like that. That should be invested into something. That is a painful thing, I'm sure. And of course, David would know more about this. This is his whole bailiwick here. Now, there is usually 3 layers of ligaments, tendons, whatever you want to call them, connective tissues. And they slide back and forth and do all kinds of things. Now, in order to slide back and forth, they're in their own sheaths. And their sheaths are, you know, coated with, I think they call it synovial fluids and things like that. Now, this particular stuff right here, see that little bumpy stuff? That is what I'm going to call slurpees, which is small leucine-rich proteins. Look at it really careful. I don't know if you can see it or not. Anyway, that is, it's a real bumpy slurpy stuff. And I have that, and it's blood red. And anyway, this is the tendon mat assembly. Alright, that tendon mat assembly and that tendon ball is microscopic. This is a tendon from, I believe, a tendon mat, and they all break in the same place where that strap goes across. This is the slurpees. This is another strap that sat right on top of here, and they slipped across. And that is the fibers that come down through there and into this ball. And that ball usually sits into something, and this one I assume was in cartilage or something like that, in some loose connective tissue. And it pulls out. Now, I have other ones where the fibers are missing because they were in some form of a pH condition that ate them out of there. That's how how these things form, tendons. Now, that ball, like I said, is the size of, well, it's microscopic. I mean, it's tiny, tiny, tiny. Now, if you look above here, there's the formula for the surface area of a sphere. And if I put in, you have to be positive entry, so I'm going to put in 1 is the radius, and therefore the surface area is 12.57. Now the radius of 1, when you talk about this thing, this radius would be at least, I would say, let's just say 100 times larger. I mean, it's obviously much larger than that, because you wouldn't hardly see this. You need a microscope to see that in this other one. Whoops. Now, so that was a 1, gave us 12.75. Now, if we go for this one, whoops. If we go for this one here, and we say that's 100 times bigger, so that's 1, 0, 0. Now we've got 1.26 times 10 to the 5. If that was 1,000 times bigger, we would have 1.26 times 10 to the 7. I have no clue how big that is, but 10 to the 7 is a lot of zeros. So you understand that the surface area of a ball goes up absolutely phenomenally as the diameter and the radius increase. This was always the skeptic's conclusion, that the tiny diameter of the little tendon balls and the investments would never hold up some big creature. Well, no, wrong. All right, David, this is about how the tendons and the ligaments and even the skin attaches to the layers of the skin. These are some of the investments that I'm talking about. And they come up and they clamp like a ball, just like that. And the skin is on the other side, and they clamp right to the skin, and then there's one on the other side, and it clamps down to the underlayer, and in between is this areolar tissue, which is the loose connective tissue. That's what I'm saying. Now, you're going to have to see if you think I'm correct. Now, this is flesh. All right? So I'm saying the flesh is below. It's on that side. This is this tendon emplacement, and you can see all of the little tags around here, and this is the investment that goes this way, and there's slurpees on there, SLRPs they call them, the small leucine rich proteins. Now, so those invest down in there, and here is one I'm going to show you. This is a fingertip. Let me see if I can get in here, we get a little more light. Alright, here's the way it invests. If you can see these balls right here, that circular set of balls, that's stuck down this way and held onto the skin. Alright, and it held onto the skin with all those little fibrils. There's another one over here somewhere. Right over here. I mean, they're all over the place, but some of them are very, very prominent. And they have spikes. They literally have spikes that grab just like that into the skin, and the other direction they grab just like that into the basement layer. And I have them in all the transition layers. This one here, you can see the spikes. The only thing that's missing here is the skin. The skin is missing off of this one. Alright? And this one here, the skin is missing. It's what they call degloved. That outer layer of connective tissue is gone. It would have hooked into these angular slots all over the place. So that's degloved. And this one is completely degloved down to the basement layer. All the areolar tissue is gone until you see the emplacement of the artery, which I always tell you blows out, which it does, and then the vein side does not blow out because it's clamped. You know, and there's a vein right there. It leaked a little bit, but they clamp. And the veins are the ones that always leak. And I have this over and over and over and over and over. And this is where the areolar tissue would have invested into this basement layer. And then that layer wraps the bone, which this is the silhouette, exact silhouette of a human fingertip. And it even has the apical tuft on the end, which is the gnarly little thing that holds all these little balls. And that's what it is. And these are from big creatures, but this is nothing. I mean, this is the way you see it, and you're going to see it in a minute, because I told you, I have never shown anybody on the face of the planet this yet. You're the only ones to see this. Well, the first, because it's going on the internet, but I'm just done hiding this stuff, because it's time to let it loose, that's all. Alright, David, so you saw the skin investment. That goes down and grabs and turns around this way and grabs. So that's between the areolar tissues. And I'm sure it goes other places. But it's very characteristic. I have a lot of examples of it. Now, then you go into the bone implant. And that's where you get this. That's a regular ball. And inside that ball, if you can see, there's all those little holes. Those, I believe, are the Sharpie's fibers, or at least they're tendrils of some sort. And they may, but anyway, this is all, this is something, I don't want to go into too much detail, everybody will get bored. But that is this type of implant. Now there's other types of bone implants that hook into these, see that right there? That is where a ligament attaches. And this one over here, there's another one. Over there. Alright, and that's what makes that bone do what it does. Now this is cartilage, and it goes all the way across over to here. It's cartilage. And that's when this wears down, you get hurt. And these are your, I believe those are blood supplies. I'm not exactly sure, but that's the arterial foramen. This here, these little holes, they call those canaliculuses, and those are blood supplies, canals. Now, the whole thing is wrapped with fascia, and there's a triangle. I don't know if you can see it or not. I suppose you can see it. The way this is, it's called tunica in the Greek days. And it wraps around and invests itself just like a tunica. You know what I'm talking about, tunica. And it's a fabric blanket that wraps around the bone. And now this, I would like to have Fabio and Jesse take a look at this, because I'm sure this will scan. Well, I'm not positive, but if it would, it's going to be really interesting, because you'll be able to see the distinction between the cartilage. You know, there is actual cracks in here, and that would come off. And you know, in my other videos I show the strip bones, the differences. You guys have probably, I hope you've seen it. Anyway, that's the bone investment type. And then you also have the one I just showed you a minute ago, which is this one here. These are like triangular investments. They go down and out, and they fill right into these triangles, and there's Sharpie's fibers everywhere. And then they come down and attach into the muscles with these little flaky, pine cone looking, shingly looking things. And that attaches to ligaments. And those are what I find. Now, in addition, obviously, fascia, this is exactly what we're talking about, and this is on everything. And David, I believe your exact words were that I'm 100% correct in what I'm saying about this. So I need you to be with me to say that to people, because it's true. And you're one of the only ones that understands it. So I need you, brother. So anyway, get back to me on this one. But anyway, I'm going to show you some more in your field, and everybody else will see it at the same time. And I'm going to show all the different things that I need to have tested. Alright. This is important to understand. That's the little strap that runs from the tendon mats down onto that ball. And that ball, it looks round in there, and perfectly round, but it isn't. It's a spiky little, really spiky ball, and I'll show you what it looks like. That is supposed to be inside of something. Now, sometimes it goes into, I'm not sure where it goes. David will know about that, but that is supposed to be implanted, and that's what holds it. It anchors this, and the mat does what it's supposed to do and pulls your fingers around and stuff. Now, this is my representation of what that does. It's a flat mat. It comes out and there's Slurpees on the top because something slides across it, and it lays there and digs right in just like that into tissue below. And these always have two very apparent blood holes on the sides. Now, that is a tendon implant. You saw the one I just showed you, the little ball. That little ball is literally the same size. Well, the little ball on this one, this is a microscope shot, which obviously this is like 1,000, 2,000ths of an inch. I don't know, whatever they are. They're not very big at all. Now, I told you to hold on here, buddy. Here it comes. This is the size of the tendon enthesis balls that I am finding, and that is a ball right there. There was two of them. One slid across the top. That's the Slurpee layer, and that is the strap that ran back. There would have been a ball attached to here. You know, I cut it off, and this ball was just absolutely totally round, just like a baseball. You see the architecture of it, totally round. And this, inside there, those little white flakes are the fibrils that come down and implant into whatever it implanted into, the bone or the tissue below. And this is the external surface of the tendon. It's a layer. It could be the, you know, the periosteum, I think they call it, or it could be the fascia, but it has that same material, tunica fabric in there. It's very apparent under the microscope. Now, those invest in the bone, and this is thousands and thousands of times bigger than what is in a human being. I mean, it's just gigantic for a human being. But this is tiny. This is what I'm saying. Hold on to your hats, guys, because here's what a big one looks like. All right? Hold on. I got to get back for this. There it is right there. This is what a big one looks like. This is the strap coming in. This is the Slurpee layer at the top. And these are the spikes all the way around it. And I can show you that, and I can pretty much prove it. There's your blood supplies. Right there. Those are the two blood supplies on this side. They always go on this side. Now there's another one coming below this from over here, and that has its blood supplies. But I believe they're usually, it seems to me they're on the left side. Now, these spikes, they're what they call plagioclases. And those plagioclases, you see this? They dig in just like teeth. I'm not kidding you. They just dig right in just like teeth. That's exactly what they do. And this is the investment of skin. All right? That's the investment of skin. I don't know what to say, man. But that thing is like a dinner plate, and that is what skin is on some gigantic creature. I mean, and this is not even the biggest stuff I have either. So all I can tell you is you're into something here that it's and that's what it is. I mean, that's this here. If you look at it under a microscope, that's Slurpees. That was blood. And I've shown you the red blood, and this is the same thing. Hold on a second. I have another one. Whoa. Here it is right here. You're gonna put a little water on it. Give me a second, guy. Alright, this is the one that I showed before. You got to put a little water on it to get dry, and you can't see hardly anything. But this is this. The tendon came down, and then the strap ran over here, and I cracked this all off. And that is where it invested below. That is where it dropped right in there. That's the center, really. And you can feel it. There's a depression right there. That's exactly what it is. That's the center. Oops, there's a center where I broke this off. You can feel a depression there too. And this would have laid out across this whole surface. and that is what slides. This is a tendon assembly. There's 3 of them in here. And the plagioclases, which are these flakes, these white fabric flakes, they're very brittle and hard, are the same plagioclases as I show in this. These right here. And the reason these are showing up instead of being completely covered over is they've been etched with acid. And the acid is from the volcanoes, which are right in this area. And the acid gets in and eats them away. And there are places where they're not eaten away because the acid hasn't got in. And that's one of them right there. You probably can't see the difference in color, but that is what they look like. And I have better shots of this. This is all scratched up because I sent some of this to you, Tom. This is the one you're getting for the DNA. And I think I called it tendon assembly or something. But these will snap right off of here, and you find this slurpy layer everywhere. But acid, the pH is the key. And this is what they call limonite. And this particular, I think they call it limonite, I'm not sure. But this particular stuff is the product of volcanic acid runoff, extremely low pH acid, which causes the material to change. And I have other examples. It's just like this. This was fascia. All right, and the blood surface was out there, but when you hit it with enough acid, it gets rid of all the organic stuff. Now this is what fascia looks like before you hit it with the acid. And that has all of the crystals and all of the blood inside of it and all that stuff. But once you put this and soak it in acid, it eats all that stuff away and you end up with something like this. So anyway, and Tom, you are getting fascia from this. For the DNA, I took it right from here. And that's the lower investment of a lung, and that looks like a human lung to me. I don't know what anybody else can say. I might have taken some out from up here too, but it's the same lung. So anyway, that you're getting, Tom. And I mean, look at that thing, man. This is unbelievable. I don't know what to say. The world is crazy, but it's what it is. Anyway, this here is a lung, and this one I'd like to have you guys, Jesse, Tom, take a look at this. This is a lung. Those are the lobes of the lung. Very, very weathered away, but it's completely gone. The fascia is gone. All of the outside articulation is gone. What's left is the internal passageways in here. Now, also what's left is some of the back, the guy's ribs in the back. This is the lung, and he died in this manner, and eventually it eroded away, and you had this sort of stuff on the top. But the back is still here, and the ribs are still here. There's a lot of, like this, I don't know if you can see that or not, but there's bones all over the place in here. And there's bones on the side. You can see the actual ribs going down. Now, if you have that 3D stuff, this would be pretty cool to see. It was some kind. I think it's supposed to be like this. I would say if this was a human being, it would be a left lung. And there's the top investment. There's the bottom investment. So anyway, that one I'm going to send to you guys, Tom. I'm going to send you this one too. This is what they call an apical tuft. On our fingers, it's like about a quarter of an inch on the tip, and then these little balls implant in there. And I have other ones to show the exact balls implanting. And this one here actually is the same ball implant on the end here. This is a fingertip, and it has I've got all the articulation on this. That might be something I should send you, Tom. I mean, Fabio. But anyway, I'll send a bunch of stuff. I really, I need it looked at. Now, This is a lung. This is a lung that was in acid. I mean, I didn't put it in acid. It was in acid. Now, I don't know what it was, a big monkey or something. And that was the corner investment that they all have. Wraps around, tags it in. Now, I'm not sure how that works in the body, but I mean, it's all here, the same architecture. These are what they call vugs. When they eat out the holes in the lungs, they think they're just holes from volcanic bubbling. It's not. Those are the holes that were in there from the airways. Now, they fill up with semi-precious stones, actually crystals. And there's some in here, I don't know where they are. I'm not going to bore you with all that stuff, but that's just, in the other ones I have, in the ones that have not deteriorated, like that actually is a lung, believe it or not. That's a lung. I know it's hard to believe, and I have other ones. I have a lot of them. Lungs particularly well preserved. This one here, as you know, I've been saying this is a lung, and it is. I can guarantee you that. And inside of there, it has some of that same sort of stuff. You know, it'll have, something forms it, and I can show you. I'm going to show you some crystals that are inside of lungs that blow your mind. Anyway, Fabio, I told you, buddy, I was going to show you something to knock your socks off, and I got to go even further past this. All right, what you're looking at right there is this slab, this one layer of tendon. Believe it or not, I mean it is. I'm telling you. There's the blood, the vein and the artery. All are running out, and this one didn't run out. And this is where the Slurpee runs on the bottom. And if you've seen my video on the little finger and how veins turn into crystal tubes, that is a vein. And that is the artery. One or the other, vein or the artery. But you see this? This is the size of that vein. And that's why you have this structure. And they crack on the planes of the tendon layer. And these are those emplacements. And that's one layer of tendon. These creatures were big. You know, I did some calculations, and it's hard to believe if I'm right.